sorry I couldn't be with you today to help go over this, but we are going to go through your study guide on this so that you can watch it since I have us up here today. So the first question on your study guide says, given the graph of f of x shown below, answer the following questions. So we have already learned how to do this, but we're going to walk through each of it. So find the value of the function of f at 2, f of 2. So we're going to find 2 on the x-axis. We're going to see where it hits on the y-axis. So for this answer right here, you should have 4. Okay? So you should have a 4 for f of 2. Now we're going to do the domain and range of function f. So we know that the range, or that the domain is going to be these x values. So we have the domain is when x is less than or equal to, or greater than or equal to, and less than or equal to. And we have -9 as our smallest x, and we have +9 as our greatest x, okay? So that's what you should have gotten. So then we're gonna do our range, and our range is the tallest y and the smallest y. So our range is going to be y is greater than or equal to and less than or equal to our smallest, which is -3, and our biggest, which is 8, okay? So let me go ahead and make sure that you guys can see these answers, okay? So can you see that? Oh, except that it is backwards. So we're looking at domain, -9 greater than or equal to x, less than or equal to 9, and we're looking at range, -3 less than or equal to y, less than or equal to 8, okay? So I'm putting you back on the desk so we can keep going. So now we have the average rate of change. So we're gonna look at the average rate of change from the interval -9 to -5. So when x equals -9 to when x equals -5. So we're gonna look at this line right here and find the rate of change. So what we're gonna do is we're gonna use that y2 minus y1 over x2 minus x1, okay? So we're gonna do that. So when we do that, we are going to get this point right here, which would be -9, +3, and we're gonna get this point right here, which would be -5, -3. And we're gonna make this be our y2 and x2, and this be our y1 and x1. So we're gonna end up with 3 minus a -3 over -9 minus a -5. So this becomes a plus, so we get 6 over plus a -4. We already knew it was going to be negative, right? Because it has that negative slope, okay? So we're going to get 6 divided by -4, and we would end up with -6/4. But what goes into both 6 and 4? 2, right? So how many times does 2 go into 6? We would get -3. And how many times does 2 go into 4? And we would get 2. So here your answer would be -3/2, okay? Now we're going to write one of the x-intercepts seen in the graph in function notation. So since we're writing it in function notation, we know that it's going to look like this. F of the x equals the y value. So we know that it is going to equal 0 because x-intercepts occur when y equals 0, okay? Remember that. So now we're going to find what the x is when y equals 0. So it could either be, let me erase this line so you can see better, okay? It could either be -7 or it could be 0. So those are both places where it crosses that x-axis, okay? So we are going to pick either one. So I'm going to put f of 0 equals 0 and f of -7 equals 0. So those are the answers that you could have gotten, okay? So let me show you again. Again, it is going to be a little flipped. Maybe I can work on that. Oh, and I forgot you can take pictures. So I will take a picture once I get the final one so that you'll have the picture of the answers, okay? Now we're going to name an interval that shows a proportional relationship and explain our reasoning. So I'm going to go ahead and erase everything off the board so that we are, well, I don't know. I'm trying to think about for the picture. So I guess we'll just keep it on the board, and I'm going to do blue to show the proportional relationship. So proportional relationships always look like this. They always start at 0, 0, and they're a straight line, okay? So when we look at starting at 0, 0, and a straight line, the proportional relationship that we would see is between x equals 0 and x equals 2. So that would be the answer that you would get, okay? So again, I'm going to put this up here, okay? I'm going to take a picture. Okay, so that you have all those answers. I am sorry it's backwards. Now we're going to move on to number 2. Okay? So it says, use the situation below to graph it, okay? So we're going to read each situation and make it happen. So all these situations, A, we're going to identify the variables and units in the situation and label them on the appropriate axis according to whether the variables are independent, X, which is down here, or dependent, which is Y, okay? So we are going to do time down here and miles right here, okay? And we're just going to make each of these little boxes be 1 and 1. Okay? So, the very first one, it says she walked 3 miles in the first hour. So, we are going to describe this situation by, at this point, 3 miles in 1 hour. So, 1 is the X, the time, 3 is the miles, doing this. And then we're going to draw a line to it. Okay? It should be pretty straight. Then, the next thing that happened is she was getting a little tired, so she only covered 1 mile in the next hour. So then, at hour 2, instead of going 3 miles, she only went to 4. Okay? So then it would look like that. Okay? Now it says, Adriani then decided to take the bus to get close to her destination, but had to wait for 30 minutes at the bus stop. So then, for 30 minutes, we're going to put her at this exact same place. So it's going to be that flat slope. Remember we talked about how sometimes they have flat slopes? Okay, so it looked like that. Then it says, once she got on the bus, she then traveled 2 miles in 30 minutes. So now we're looking at, she's going to go 2 miles, so she's going to go all the way up to 6 in just the rest of this 30 minutes. So you're going to see, so if you actually wanted to do your graph in terms of 30 seconds, so like 30 seconds an hour, it might be easier to see here. But right now, we have it in minutes, so we're there. Now it says, Adriani got off the bus and waited for her friend to meet her at the bus stop. So now what we're going to do is we are just going to do this. Just have a straight slope because she's just waiting for her friend to get there. We don't know if she waited an hour. We don't know if she waited, 2 minutes, but we're just going to put that steady slope starting there at where she did time, okay? So now we have A, identified the variables in this situation, and we labeled them on appropriate axes. So we have our x-axis, which is time. It's our independent value. Then we have our y-axis, which is miles, and that's our dependent value. And then we're going to think about graphing the situation and be sure to think about rate of change, intercepts, and point where the actions change. So we did all of those things. So we are now done with problem 2. So I'm going to take a picture because hopefully I can show it to you, okay? I'll try and put all these pictures in the team, so if you have any questions about the actual answer. Okay, now we're on to number 3. So, we have that Lucas was walking up the stairs to get to class. 5 seconds after Lucas starts, Romeo starts running up the stairs to get to class. Suppose that Romeo starts 5 seconds after Lucas and increases his elevation by 4 feet every second. Lucas charts his progress and makes the following table. Okay? So, what that means is in this scenario, we have Lucas, and we're going to graph his based on a chart. Okay? But for Romeo, we are going to have to create an equation so that we know when his moves up. So, Romeo starts with 5 seconds. So we know it's going to be y times a number times x plus 5 seconds. And he travels 4 feet every second. So here we're going to put a 4. Because after the amount of seconds, he is going to travel 4 feet that he's walking. Okay? So now we're going to graph both people's elevation versus time in seconds. So I'm going to graph Romeo's in yellow and Lucas's in orange. Okay? So we're going to have each of these be, so this is your time, and this is your elevation, or how high they are, okay? So we're gonna do our elevation by 2s. Okay, so it would count by 2s. And I'm actually going to graph Lucas in green, since I used the orange for the points. Okay? So, let's do Lucas first. So we see at 2 seconds. So on this, we will do our seconds in 1. 1, 2, 3, 4. So we see that Lucas at 2 seconds, he's at 4 feet. Okay? At 6 seconds, which would be here, he's at 12 feet. Okay? At 7 seconds, he's at 14 feet. So it would look like this, okay? So that's how we would graph Lucas, by just doing the points and then creating a straight line from them, okay? Because we know it's the same rate of change. Now for Romeo, since we know that the y-intercept occurs at 5, we're going to start him up here at 5 feet of elevation. So it's going to be in between that 4 and 6. You could have done yours in just 1 point, so if you want to do that, feel free. And then we know that he's going to go up 4 over 1. Up 4 over 1. And as you can tell, I'm not actually going up 4 since I did mine in 2s. If you want to do yours in 1s, you're more than welcome to do that. So we see it look like that. Okay? Now it says, what does the point f of 10 represent in the context of the problem? So if we find 10 on here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm going to do it with pink. It is what? Where both of these boys are. So where Romeo and Lucas are at 10 seconds, right? Because our x is 10, and so we know that it's talking about that time. So that's where they are at 10 seconds. Make sense? Okay, I hope so. Now we're on to number 4. Is the function graph below linear or nonlinear? Justify your reasoning. So, linear has 2 properties. Linear equations make straight lines and have a constant slope. Okay? Nonlinear do not make straight lines and do not have a consistent slope or constant slope. So, when we look at this line, does it make a straight line or a curved line like we've talked about? Okay, I'm going to say it's a straight line. But if we wanted to check it, we could check the slope from here to here and from here to here. So the point here is 2, 4, and here is, what would you say that is? Like 7 or 2.5 and then like 6.25. So you would do the y2 minus y1 over x2 minus x1. But I'm going to call this one linear, okay? So we figured out it is linear, okay? Good. Now let me take a picture. Okay. Now we're going to move on to number 5. So it says Amy has a job that pays according to the function P of H equals 9.5 hours. So basically she gets paid $9.5 per hour. So if Amy is only allowed to work 40 hours per week, what are the domain and range of the function? So if Amy is sick, okay, or her kid is sick, or worst case scenario, or maybe she just doesn't want to, what's the minimum number of hours that she can work? 0, right? Okay, but her maximum is given by her job. So the maximum number is 40, okay? That's the max numbers of hours that she could work that week. So we know that the hours, 0 is less than or equal to the number of hours, which is less than or equal to 40. So that's how you would write that domain. Well, now let's talk about pay. So if Amy works 0 hours, how much is she going to get paid? $0, okay? But if she works 40 hours, how much is she going to get paid? So we're going to take 40 times 9.5. So I'm going to grab a calculator so we can do it. 90 times, 40 times 9.5 would be the max. So we get that the max amount of money she can make is $380. Okay? So that would be your range. And this would be your domain. Okay? Taking that picture. Okay? Now we're moving on to number 6. Okay, part 6. Classify if it's a function or not a function. Guys, this is super easy. Remember, if it's a function, then every x only goes to one y. If it's not a function, then that's not the case. So, looking at number 1, we only have every x show up once. So guess what? We know that this is a function. So relation 1 is a function. Relation 2 has only one x show up. Every x only shows up once. So we know that this is a function. It doesn't matter that some of them go to the same y's. We just care about if all the x's only go to one y, not multiples. Well, over here, we have 2 x's, 4. We want to make sure they go to the same number. And guess what? They don't. So this is not a function. Okay? So relation 1 and 2 are functions. Relation 3 is not a function. Okay, now it says describe how you classified each of the relations. So you would just say something like, I chose functions if every x / input only went to one y / output. Okay, so remember, another word for x's are input, another word for y is output. Okay, so I'm going to take a picture of this. I hope you guys are paying attention, doing good so far. Hate that I couldn't be here with you. Okay, sorry. We're going to keep tracking along, okay? So now we're on number 7. Oh, just kidding. There isn't a number 7. There's only 6 problems, okay? So we're good. We're done. If you have any questions, feel free to ask me this afternoon. I will be here this afternoon, okay? Bye, guys.